the PDU, the protocol data unit, in each layer contains the payload data that is being transmitted. And it's a common to prefix a header which contains information required for the payload data to be transmitted, such as the addresses of the source and destination nodes on the network, to the payload data. So sometimes the protocol data unit, PDU, also has a footer here that is suffixed to the payload data and contains values needed to ensure correct transmission, such as error checking information. And here in this diagram, I created how PDUs are laid out in the IPS. Remembering from the previous lectures, IPS means Internet Protocol Suite. Here. So let's get started with the application layer here. So you can see here we have layer 4, we have application, station, internet layer, and the link layer. Now I will explain all of these layers and their payloads, headers, one by one. So the TCP header contains a source and destination port number, which is here, source and destination port number here. And these port numbers allow a single node to have a multiple unique network connections, and port numbers for TCP and UDP range from 0 to 65,535 here. And the most port numbers are assigned as needed to new connections, but some numbers have been given a special assignment, such as the port 80 for HTTP. You can find the current list of assigned port numbers in the etc services file on the most Unix-like operating system, but you can also check in from the Wikipedia from internet. And a TCP payload and header are commonly called a segment, whereas a UDP payload and header are commonly called a datagram. The IP protocol uses a source and destination headers. The destination address allows the data to be sent to a specific node on the network, and the source address allows the receiver of the data to know which node sent the data and allows the receiver to reply to the sender. IPv4 uses 32-bit addresses, which you will typically see written as a 4 numbers separated by dots, such as this: 192.168, 192.168, here 10 and 1. So this is an example IP version for IP address. And IPv6, actually let me notify here, IP version 4. So but the IPv6 here, IPv6 uses 128-bit addresses, because 32-bit addresses aren't sufficient for the numbers of nodes on the modern networks. IPv6 addresses are usually written as a hexadecimal number separated by colons, such as, for example, FA80 000 4 times 0 here. Actually, let me increase the size it here, 000, and so this is an example IPv4, IPv6 address. Long strings of 4 times 0, as you can see here, we've written like that. Long strings of 000 numbers are collapsed into 2 colons. For example, if you want to write this IP version 6 number easily, you can also write like that. For example, 1, 2, 3. So 1, 2, 3 here. Ethernet also contains source and destination address. Source and destination address. Ethernet uses a 64-bit value called a media access control address, which is typically set during a manufacture of the Ethernet adapter. And you will usually see MAC addresses written as a series of hexadecimal numbers separated by dashes or colons. For example, MAC address writes like this. For example, 0A with dashes. We will separate here 28, 99, 3, A5. So this is an example media access control address. And the Ethernet payload, including the header and footer, is commonly referred as frame.